Hello, welcome to another episode of Introduction to Operating Systems and Virtualization. My name is Scott Neal. Today we're going to be talking about shared resources and domains. We're going to start off today's lecture looking at the principles behind sharing. We're going to talk about sharing disks and files, talk a little bit about the history of sharing and what that means in the process of that. We'll be defining a workgroup versus a directory service. And in particular, a lot of today's lecture is going to be dedicated to Active Directory. That's the Windows equivalent of a directory service, and predominantly we're talking about that because Active Directory is pretty much the de facto norm for most corporations today. So if you go work in an IT shop somewhere in a corporation, chances are you can be working with an Active Directory domain. So we'll be talking in some detail about how we can facilitate sharing through the use of accounts and groups. We'll talk about some of the security considerations with setting up sharing through Active Directory. And then we're not going to leave out Linux and Mac totally out of this equation. We'll talk a little bit about how they share before we finish up talking about printer sharing through server or client operating systems. Really, since the 1990s, operating systems have been network capable, and they usually require a network administrator to set up sharing and establish some sort of security baseline through the use of accounts. Those accounts usually have some sort of password policy applied to them. And then we can create groups to help facilitate sharing by organizing users and even computers into the roles that they use in the organization. Accomplish each of those today. Network operating systems really started off in the 1980s in a very simplistic way. Back in the 1980s, if you wanted to share something, you did have the ability to download a file from a shared repository to a workstation, or through the use of some third-party application, you can make changes to that file and then upload it again for someone else to modify or to use as they wish. And that was great and all, but I think we realized very early on that there had to be a better way, a more efficient way to share resources. And so I think Bill Gates put his head together and came out with, in 1992, Windows 3.1. 3.1, or Windows for Workgroups, really ushered in the era of the workgroup, which we'll talk about today. And workgroups did evolve our sharing capacity somewhat, still limited, not very scalable. And so it didn't take long for us once again to realize we really needed to evolve that sharing capacity. One of the ways that we did evolve sharing was through the use of NTFS, and it was introduced in Windows NT in 1993. We still use NTFS predominantly as the file system of choice if you're going to be sharing resources in a Windows environment, because it lets us micromanage those resources. And in Windows 2000, we saw the actual preview of Active Directory. It came out in 1999. That's when we first got our glimmer of Active Directory. They did some modifications and tweaking of Active Directory as they were developing out the application. And with Windows 2003, they had nearly perfected the Active Directory infrastructure. And because it really changed and evolved the way we share resources, it was quickly adopted by a large number of organizations. And today, it is the de facto norm for most organizations to use Active Directory for their network. Server 2008, Server 2012, and Server 2016 have all seen remarkable improvements in how Active Directory works and given us a lot more flexibility and a lot more things we can change with Active Directory. So I don't see the use of Active Directory diminishing anytime soon in most organizations. Sharing resources over a network does require an orchestrated approach. We do have to facilitate sharing through the creation of security groups. We do need to be vigilant in how we set up account policies and allow our users to connect to the network through the use of user accounts, maybe incorporating multi-factor authentication. We also have to then use groups and users as a way to facilitate sharing on the resources themselves by assigning them the appropriate permissions. And then, even though we have done that on the file system, we still have to go in and actually share those disks and folders for network use. So let's start off with what is a workgroup. As I said before, workgroups really showed themselves for the first time with the use of Windows 3.1. It does allow for peer-to-peer networking from one computer system to another on a network, and it's a very simple networking solution. It's certainly better than having to download the file onto your desktop and modifying it and uploading it again. But it's not very scalable. It does require a significant amount of manpower to manage. It's not the most efficient way to share resources. And the way peer-to-peer networking works is that every Windows box on the network is its own little world. It's its own little local world with local users, local groups. And you have the ability to connect to that box and to authenticate to that box if you have a local account on that box that you can authenticate with. Astute network administrators were smart. They just gave everybody the same username and password. And even though they were logging on to each box separately, to the user it seemed fairly seamless. They had to reconnect every time they connected to a resource, but it was the same username and password, even though someone had to go behind the scenes and touch every box with that username and password. And in reality, it's not the same username and password because each local machine has its own username and password. We do a little bit of that, or we give the user the same feel today with domains as well, but we'll talk about that later. It was not the most efficient way to share resources, and that's why directory services are really where it's at today when it comes to sharing. Directory services do provide three important functions. They allow us to centralize the listing of resources, and because we've centralized those resources and indexed them, it does allow us to find them much quicker. And the centralization of resources also allows us as network administrators to easily access and manage those resources through the use of a central database. And that gives us a much more efficient way of allowing our users the use of single sign-on and a way for us to facilitate sharing or restrict sharing as we see fit. So if you are a Windows administrator, then the directory service that you're playing with is Active Directory. It's not the only directory service out there. I learned directory services through Novell. Novell in the late 90s, I'm beginning to disclose my age here, the late 90s and early 2000s had a significantly higher market share than it does now. Now it has less than 1% of the market share. But Novell had a very well-developed directory service in the 1990s. In many ways, and actually in most ways, it was very similar to the way Windows Directory Services works. But Bill Gates was far better at marketing and also offered organizations some other strategies that made their product at least appear more superior than Novell. And so the Windows Server 2003 really outshined the Novell equivalent, and I think that was probably the beginning of the demise for Novell. Anyways, in Active Directory, the fundamental component for containing information about the network resources is called a domain. Domains are hierarchical, like most things in Windows world, file systems, and so on. And objects or resources are grouped within that domain, and that domain does represent a security boundary. If you have, whether it's one domain or a domain with subdomains in it, that represents a tree. And a tree, if you put more than one tree together, just as you would think in the real world, that's a forest. But bear in mind that in Windows world, a forest can just consist of one tree. So if you're a network administrator and you're managing a small business or a business similar to the one that we use for our Server 2012 and Server 2016 course, that one domain does represent, even though it's a single tree, it's also a forest. So you can, in Windows World, have a forest of one tree. But a forest houses one or more trees, and that forest does represent, like a domain, a security boundary in and to itself. Domain controllers are really the devices, the servers that house all the Active Directory databases. They allow users to authenticate to it, and it allows us as IT admins to manage those resources. So a big shift from the workgroup, right? Because in a workgroup, all the accounts are local to each machine. We've done away with that. In domains today, our users do not have local accounts on every box. They have one account. That account sits on a domain controller in a database, and when they authenticate to the domain, that authentication occurs at the domain controller. That domain controller then gives that user a token, very similar to the way you get a driver's license at the driver's license office. You show them your birth certificate and another form of ID to prove that you are who you are. You get a driver's license. And then you can use that driver's license or that token to authenticate to resources on the network. It looks at the token, says, okay, I believe that you are you. You successfully authenticate to the resource like a file. And then it looks at the permissions in its access control list that sits with each file and folder and resource on the network to determine what level, if any level, of access you have. So a couple things to be aware of here. First of all, you have a token. That token really just defines who you are. So just like your driver's license says you're a Class C driver, you can drive this type of vehicle. That's very similar to the token that you carry around. It says, hi, I am an IT manager. This is the role or the roles that I perform in the organization based on these security groups. And then you use that and show that to every resource that you touch on the network. The resource on the network has its own list of those items that it will then look at to determine whether or not you have any level of access or what level or degree of access you have. So that's a very important concept that you learn about with domains. We'll talk more about this if you look at our admin course. We'll talk about it in significant detail. Inside, if I open up a domain on the domain controller, all of our resources are grouped together in different ways. One of the ways that we group those together are in containers. A container is really a folder that is used to group together resources in the directory service. So for instance, when you build your domain, scott.com, you have users and computers by default in there, and those are containers. And so whenever I create a user, by default that user will be stored in the user's container. Anytime I add a computer to the domain, that computer will show up in the computer's container. And I cannot assign different rules to those containers. They're just there as vessels to hold objects. If I want to assign rules to a group of objects, then I will create an organizational unit. An organizational unit just shows up as another folder in the domain. But the difference between that folder and a container folder is that I can apply certain rules to that folder, and I can make my users, for instance, see a different desktop image, or to have a different home page, or access a different set of privileges on a server or a desktop, or have a different password policy. So organizational units play that kind of a role in our organizational structure. If a domain structure looks very similar to a file system structure in its hierarchical order. So I can have organizational units inside organizational units, or container units inside organizational units, and have different levels inside that structure. If I go all the way to the top of that structure, just like a file system, the very top of that structure is the root domain. The root domain is going to be the top layered domain, so like scott.com, amazon.com, yahoo.com. These are all root domains. And for sometimes I may decide I really want to change the rules for a group of or an entity in the organization. So I may have different facilities scattered all over the world, and I want to represent those utilities and group them differently, and then assign them new rules or allow for greater replication control or add new security policies. I can do that through the use of a subdomain. We don't see subdomains being utilized as much these days. Most people are opting for organizational units, but they do serve a purpose. If I am going to purchase another company, for instance, and they have their own domain, I may want to create a trust relationship between those domains and increase the size of my forest, and I can do that. And if I create a one-way trust, the domain, say Amazon.com by Scott.com, I may set up a one-way trust or a two-way trust, and either way, if I set up a one-way trust, Amazon.com would become the trusted domain, and then those executives will be given access to the trusting domain that would then that means that those accounts in my trusted domain would be able to be added to resources in the trusting domain, and then those executives could have access to the resources in Scott.com as well. So if I actually sit and show this from a illustrated point of view, a forest, as I said before, can consist of one domain tree. Scott.com certainly would be a tree into itself and a forest of one. I can, if Scott.com grew significantly over the years, I may opt to set up subdomains to significantly change, say, security policies or enhance my replication between those domains. I may opt to create subdomains for each of those organizations that are in my domain as a means of grouping those resources together and setting up some significantly different rules. And if Scott.com got bought out by Books.com, I could set up a trust relationship between those, and then I would have a forest of two domains, multiple domains, and I could set up that trust relationship one way, as illustrated here, or I could set it up two ways. So, as far as some more terminology to be aware of, one of the things that we as administrators like to do, we really do not like to use individual user groups or users, as a way to control resources. When you think about the thousands or hundreds of thousands or millions of resources that an organization has, every file, every folder, every device, whether it's a printer, whether it's another computer, represents a resource. And to add users to these resources on an individual basis would eat up a large percentage, if not totally occupy our time. So one of the ways that we make this much more efficient is through the creation and use of security groups. Security groups are used to enable access to resources either on a standalone server or your home computer. You can set up a security group. You have some security groups by default. Users, administrators. Those are security groups, and you can create a group for your children and give them certain accesses. You don't want them to have access to the control panel. You can do that. You don't want them to have access to the pictures folder. You could do that, and we do that through security groups. And then you can add users to and from the group and not have to worry about adding them to and from each resource. So in Active Directory, we use security groups to facilitate the sharing of resources by assigning users and computers to those security groups. We then use the groups and set up those resources with groups, and that does ease the burden of controlling access and resources on the network. Instead of having to go into the file server, the only thing we have to do is, whenever someone changes a role in their organization, is remove them from a group and add them to another group. And that saves us the trouble of having to go to the file server and the application server and the database server and the printer to make those changes. There's another group out there that you should be aware of if you're going to be playing with Active Directory, and that's distribution groups. For most administrators, we don't really worry about distribution groups. 90+% of the time, we deal in the realm of security groups. Now, if you're an email administrator or a voice over IP administrator, then we do use distribution groups as a way to mass distribute information and some other functions. In a small office setting, you may not have Active Directory. If you're working, I had a particular student that worked in a real estate office. They didn't use Active Directory. They really used local groups and local users through Windows for Workgroups, set up a workgroup, and they just used the workgroup. That's fine if you're working for 10 or fewer systems. You may find that prohibitive if you're the only IT administrator and you start getting beyond 10 systems and you got more than 15 users. You're probably going to want to create a domain and set up a domain controller as a way to really administer those resources. So the following types of groups can be used to install, can be used on all Server 2003 through Server 2016 operating systems. You can have local groups. Local groups sit on the server. They're not part of the domain. The only exception to that is the domain controller itself. Once I have taken a server and converted it into a domain controller, all of its local groups are going to be domain groups. The local administrator account will become the domain administrator account for the entire domain. Domain local groups are used when there's a single domain or to manage the resources in a particular domain, and then I can add use local and universal groups to access resources. So what we're setting up here is a nesting effect. And if you know that you're going to be a domain of one domain, by default your security groups are going to be global groups. They're used to group accounts from the same domain so that those accounts can be access resources in the same or other domains. If you're setting up one domain, you'll probably, if you go in and look at a small domain, you'll see that all of the groups are probably global groups. That's fine. You can always start creating domain local and universal groups if you find that your organization is growing to that point where you have to create nested groups. And the reason why we talk about this or mention this here is that when you start taking taking our server admin course, or you start looking particularly at our advanced server admin courses where we start looking at large groups of organizations, the only way to facilitate access to multiple domains is through the use of a universal group. They're used to provide access to resources in any domain within the forest. But you can't just throw users in a universal group. You have to set up a nesting sequence between domain local, global, and universal groups in order to facilitate users having access through multiple domains. All of these groups are also defined as security or distribution groups. So it's important to know whether you're working in a security group or a distribution group when you start setting these up. There are some guidelines to help simplify how we use groups. We use global groups to hold user accounts as members. This is the way we set up a simple domain. By default, when you create a security group, it will be a global group. That's fine. Give members access to the resources by making a global group. The global group members of the domain local or universal group or both. Use the domain local groups to provide access to resources in a specific domain. So avoid placing user accounts in domain local groups. Give domain local groups access to shared folders and printers. Then we're going to use universal groups as a way to provide extensive access to resources. So these are great for simplifying access when we have multiple domains. And we do that by giving the universal groups access to resources in any domain, tree, or forest. So they are truly the bridging group or security group that allows us to facilitate access through multiple domains. We manage user accounts, account access by placing accounts in global groups and then join those groups to a domain local or universal groups. This is the Microsoft way of doing things. As I said before, it is not uncommon, it's been standard practice in most of the places I've been to just set up a global group, use that global group, and attach that global group to resources. When you start getting bigger and you start having to think about setting up through subdomains or multiple domains access for a user accounts or a group of user accounts into those areas, then you can create a nesting effect. You can go back and create a domain local group, put that in the resource, move the global group into it, and so on. All right? All right. So if you are really curious about nesting, we can talk about that when we start looking at NOS 230, 231, our server courses. Using the Windows servers to share resources. So the way we do this, of course, is through the account, the user account. We start off by setting up user account policies. Now, user account policies are certainly not etched in stone. We can go in and change those at any time. But if you are walking into a small organization and they've never set up a domain, then one of the things you'll want to set up first after building your domain controller is an account policy before you create your user accounts. So they're going to be used to set the restrictions and set up the security for that domain so that only authorized users are going to be able to access the domain resources through the use of these accounts. There are certain parameters that I can set up as account policies. There's a password policy, there's a lockout policy, and we can even set up the encryption policy through Kerberos. That is the encryption that we use for these accounts that Microsoft uses. So we can set up these through these three types of policies a way to lock down the system. Account policies, of course, should be configured before setting up those user accounts, and consider using multi-factor authentication. So today, it's not uncommon to see more than one way to authenticate to a network. So you may have to put in a password, which is something you know. You may have to have something with you, like a pass key or a user token or a smart card to put into the device and then put in your password. That certainly is one way of doing multi-factor authentication. And if you've been watching a lot of movies lately, you may have seen multi-factor authentication with retina scans, fingerprint. If you're logging into a laptop that has a fingerprint reader, that is certainly multi-factor authentication if you use your fingerprint and a password to get into the box. Multi-factor is becoming more and more popular, particularly with so many account hackings that have occurred in recent years. You're seeing organizations slowly moving towards the multi-factor authentication as the number of false negatives has decreased over the years on this new technology. All right. There are some password policies that we can certainly set. Password security, of course, does enable you to set requirements on how we can set passwords. So there are several different things we can change as network administrators to make a network more secure. We can, first of all, enforce password history. So password history really is whenever you create a password, that password is saved. Albeit it's saved in an encrypted directory, you really have no access to it, but the system can certainly find it, and it can keep track of the number of times you've used a certain password in the course of that user's time with the organization. I have the ability to ensure that that password is only used a certain number of times throughout the duration of that person's stay, and that's called password history. At my old job, I think I calculated once that I could use the same password twice in 30 years based on the password history policy set up by the network administrators. There is a maximum password age, so usually set in number of days. That means that after that you've exceeded that time, you have to change your password again. This ensures that somebody doesn't just sit there over a period of time and slowly begin to guess someone's password. And if they have gained access to the account and you don't know about it, then at some point that access will be cut off because you'll be required to change your password again. Likewise, there is a minimum password age. Not as important as a maximum password age, but if you've got users that want to sit there and run through a bunch of passwords to try to circumvent the password history, there are people out there that may do that. One of the things you can do is set a minimum password age, and that is the minimum length of time that a user can change your password once they've changed it. There is a minimum password length. I recommend 14 characters or more, and I will explain why at another time. But the number one thing that you can do to improve the performance of password security is change the length of the password. The longer the password is, the more exponentially harder it's going to be for a hacker to guess that password, even with the use of automated systems. So if you could only change one thing here, it would certainly be the length of the password. And most people have complexity requirements turned on. This requires that you have certain characters. That's where you see you got to have a capital letter, a small letter, a number, and a symbol. Those are complexity requirements, and by turning this on, you do have to have a minimum of 3 of those in a password. And something that's hardly ever used, this concept of reversible encryption. Password reversible encryption is just where you store a password hash that can be accessible through the network admins. Most people don't bother with this feature. It does lend itself to a less secure network. Lockout. One of the things that, if you've ever seen a brute force attempt on a box with no lockout policy, you'll really see a log with thousands and thousands of entries in just a couple of minutes time frame, where they keep trying to break into the box. One of the ways that we can discourage brute force attempts is through an account lockout policy. This is where you can only attempt to use your password X number of times on a system to authenticate to the network. Once you have failed, say 3 times, then you are locked out, and you can be locked out for a duration of time using the duration policy. This specifies in a number of minutes how long you will be locked out of a system once you have reached the number of unsuccessful logon attempts. You can set this. The duration can be never, that you have to call somebody to get into the system. Just be advised that if you're the only network admin in a 24-hour organization, that you're going to get phone calls at 3 o'clock in the morning asking to be unlocked from a box. Consequently, a lot of us don't do that. We rather set 20 minutes or 30 minutes and make sure our users know that they'll have to wait the 30 minutes to get back into the box. It will reduce the number of phone calls to your organization, I assure you, and particularly at inopportune times. There is an account lockout threshold. That's really the limit of the number of times you can attempt to log into the box. And then there's a reset, so you can then reset the lockout count after. That is really where you specify the number of minutes between 2 consecutive unsuccessful logon attempts to make sure that the account will not be locked out too soon. These help discourage brute force attempts. Now, brute force attempts have gotten very sophisticated, and they're automated, so you can just turn one on and it will sit there. It knows whether it's been locked out, and it will try to re-authenticate the box after that lockout policy. But it will buy you some time. So if you set up your auditing correctly, you can make that, that gives you some time to try to isolate or identify brute force attempts and stop them before they get into the box. All right. Kerberos Security is the third method that we can use to enhance security. There are some configuration policy options that are available, like enforcing the user logon restrictions, which basically just turns on Kerberos. By default, that's turned on, and it should probably remain on at all times. The maximum lifetime of a service ticket or user ticket. So that user ticket, once again, is that token that I was talking about earlier, your driver's license that you walk around with that will, by default, just like we've made renewing a driver's license very easy, we can make renewing the user ticket very easy. For a lot of organizations, they never bother with this. For some people, they say, well, if you've been logged into a system for 24 hours, we probably ought to have a maximum lifetime of 24 hours, and then you have to re-authenticate. So there are some things that we can change there for that Kerberos policy. The clock synchronization. So the default in Active Directory is 5 minutes. So if you have a box that's on Active Directory in a directory service and it's lost its trust relationship, you've logged in with an account, even a domain admin account, and you're not able to get into the box, one of the things you can look at is the clock on the computer, because if the clock is more than 5 minutes off, the domain controller is going to not trust that box. It's going to say there's something wrong with you. And so clock synchronization is very much part of that security. So you can change that. It doesn't have to be 5 minutes. The default is generally 5 minutes. So we do configure our user accounts after we have set up our account policies in an optimal environment. Of course, chances are you're going to be coming into a Windows environment with accounts already set up, probably. In which case, if you're the IT administrator with decision-making power, you can review those policies. Just bear in mind that most of those policies will only take effect after the user account has expired. So if you change, say, the password strength policy, when that user's account expires, it will then require that user to use the stronger password policy. If you don't have expiration dates and you set an expiration time for those accounts, that will start the day that you set that policy. So a 180-day policy will start, and it will be 180 days from that point. When Active Directory is not installed, a user account can be created by right-clicking on My Computer, Manage, and then click Local Users and Groups. This works only for Windows 10, Windows 8, and Windows 7 if you are running Professional or above. If you're running a home version of these systems, then you would go through the control panel for users in the control panel, and you can make your changes there. Active Directory, when it's installed, we do this through the Active Directory Users and Computers tool on the domain controller itself. Can you create local accounts on client systems in a domain? Yes. Should you do it? No. The user is not going to understand that, for starters. We don't want the user to, we want the user to have a seamless experience no matter what system they touch. If they are building one day using one computer, or building 6 the next day using a computer, they really should be using the same account, that domain account, as a way to authenticate. The only exception to that rule for local users is if you are going to be giving them a laptop. They're going to Tibet, and they may need a way to log into the laptop without domain access. Okay, so really, when you set up a domain, you're going to be using the accounts in the domain controller, those domain user accounts. The only real local user account that you should be filling with is the local administrator account. You set that up, enable it, change the name of the account, set a very long password, and that can be a backdoor in the event that that box loses domain connectivity. Your IT admins can still work on the box through that local admin account. So that really is the way that works with the Active Directory. As far as share versus file level permissions, we can control access to the resources by assigning permissions to users or security groups. We prefer to use security groups. As I pointed out earlier, it really simplifies the way we manage resources. There are two things that we need to set up for any folder that we're going to share on a network. The first thing is share permissions. The share permissions are strictly used to gain access to the resource remotely. So to share the resources on the network, a share is going to have to be created. And then those share permissions are going to be usually limited. So you really have very limited options with share permissions: read, modify, full control. And generally speaking, if you don't know what you're doing with share permissions, just open it up to standard users to full control or modify. I tell my students, particularly in our server admin courses, that you think of share permissions like a brake. If you are worried about a network admin in the NTFS permissions over assigning permissions to a user group, you can put a break on that by setting it up in the share permissions and saying, I know that this group of users, HR will never have more than modify permissions in this folder. And I can go into my share permissions and say, HR group, modify. And I know that unless I go in and change those share permissions, that even if I go into a file or folder in that folder and set up NTFS permissions and give them full control, that they will never have anything other than modify as a group. Okay. As far as the file folder and level permissions are used to granularly access the control for the users. So if we go in and set up those permissions, as I said before, we use the sharing tab to go in and set up the basic sharing permissions for a group of users. If you don't know what you're doing, this is where you go in and say all users, full control in the sharing tab. That's fine. You're going to use the NTFS file security permissions in the security tab to do all of the real heavy lifting for our access. So we go in, we set up the file permissions for a specific group of users. So if I know, for instance, that HR is going to have access to this share folder, I may put the group HR in the sharing tab with modify permissions. And since the sharing tab between the sharing and NTFS permissions, the most restrictive will apply, I know that nobody in the HR department will have more than modify privileges in the share itself. So once I've set that up, then I can go into the NTFS permissions. I can create a folder for HR, I'll call it HR department, and then I'll add the HR group to it. And then I can go in and I can set up the specific permissions, modify. And that does the actual opening and lets them get into the folder. Now once I do that, I can go into the folder and I can say HR has only read permissions to these subfolders, and maybe they have modify permissions to other subfolders. And I can even turn off inheritance and set permissions totally different inside that folder. So there's a lot of options available for file and folder permissions. If you want to learn more about file and folder permissions, once again, take the server class. We talk about that in great detail. Alright, so NTFS advanced permissions, as you can see, there are a multitude of permissions that are available for this particular group student test. We have set it up so that they can read and traverse the folder, so they really can only see the contents of a folder. They cannot modify it, and that traverse there just lets them travel through the folders themselves. NTFS permission conflicts, so if a user account has read permissions and a folder belongs to a group that has write permissions, then that user has both read and write permissions. If the exception, of course, is deny. So if a user has read and permissions in a folder but belongs to a group which has all the permissions denied, then deny is going to override that. So NTFS permissions are cumulative, with the exception of a group with denied access, and this is going to override those permissions. Now when a folder has both NTFS and share permissions, then the most restrictive between NTFS and share are going to apply. The important rules there to remember. There are more rules in this, but we'll talk about that in the actual server class. Each user account is going to be associated with a user identification number in Unix and Linux. So we do this a little differently in Unix and Linux. Users who have a common access needs can be assigned a group just like they can in Windows. That group also has its own GID or group identification number. So even though the group may be called HR, the system's going to see it as group 501 or something like that. Permissions are then going to be used to access the resources just like you would do it in Windows. When a user logs into to access the resources, that password files can be checked to permit the logon authorization. The password file is going to contain the username, an encrypted password as a reference, which is stored in a shadow file. That shadow file is associated with the password file but it makes it difficult for intruders to determine the passwords of others because it is encrypted. Used to be that the password was stored in the password file many years ago, but that password file is not encrypted, so you can see the password file. Someone said, we need to fix this. So just remember, the password file does not contain the password. Only the shadow file knows the password. The UID can have a number as large as 60,000. A group ID is going to have the primary group ID for each user associated with it. So if I go in and look at an account for a specific user in the password file, I will have a user ID and I will have a group ID that represents the primary user account ID, which is usually users or standard user. The information about the user, such as a description of what they do in the organization. The location of their home directory. This is very similar to a home directory that you would create in Windows for all of your users. It is just a little private sanctuary where only they have access and they can store files that they don't want others to see, except of course the IT admins. And of course, if you have something that you want to run when a user logs on, that command will also be in the password file as well. The shadow file, as I pointed out, is stored in the etc. shadow directory in Linux. It's normally only available to the system administrator. It is the newest file created for managing of passwords. It does contain the password restriction information that's going to include a minimum and maximum number of days, just like Windows, the information on the password that was last changed, warning information about when the password will expire, and the amount of time that the account can be inactive before the access is prohibited. Remember, though, that Unix and Linux, we're not using a domain or directory service. This is all local account stuff. So when we go into information about the groups stored in the group file in etc., that's going to contain the entry for each group consisting of the name, an encrypted group password, which is the group identification number as well, and a list of group members associated with that group. And in some versions of Linux, every account is going to be assigned at least one group, which is usually users. User accounts and groups can be created by editing the password shadow and group files. So the nice thing about this, unlike Windows, is that since most of these files are, with the exception of course of the encrypted files, they are created in ASCII code, you can go in, you can edit them. There are some commands to be familiar with in Unix and Linux. One of those commands is the user add command, which allows you to create new users. An example of that would be the user add with -C. In this case, we have Lisa Ramirez, who's part of the accounting department, and her extension is 221. And then we can set up a password of green $thumb, and her user number is 700, and her username is Ramirez. That command is going to create that account called L Ramirez with a comment line that says Lisa Ramirez, Accounting Department, extension 221. Her ID is going to be 700, and her password originally is set to green $thumb. And you can also have the user add, user mod, and user delete are going to all be commands that are going to work with all versions of Unix and Linux, designed to delete accounts and modify user accounts as well as add accounts. Groups are going to be created using the group add account. So if I'm not happy with the default groups, I can go in and create additional groups to further micromanage how I control resources in Linux. Using the group add. So group add -G for the group number, which in this case is 2000, and that group's going to be called auditors. Once that group is created, it's going to be modified through the group mod command, very similarly to what I would do for the user mod command. Groups again deleted through the group delete command. Files are assigned a combination of 3 permissions in Unix and Linux. They're not as micromanageable as they are in NTFS. I can read, write, or execute, or represented by R, W, or X. And I do have 4 criteria for granting permissions: ownership, group membership, or other, which is the world at large, or all. So if I go in and they say the unit of a file or directory typically is going to have all the permissions. It has the ability to associate or assign permissions to other users or groups, and it will have the designation of U or user. Group members are a primary group. These are the users that have the complete set of permissions, one permission or a combination of two, such as read and execute or other. Other is going to consist of people who are not part of that primary group or not the owner. They are represented by anyone else or other. And last but not least, if your system supports the all permission, it will represent the combination of users, groups, and others. So you can associate a blanket set of policies for all. Permissions are set up by using the chmod command. In the command, if we look at an example command, chmod go, and then the actual command set -r-w-x and the star. So if we break that down, we know that G and O stands for groups and others. And we know that the dash is going to remove a permission. So -r-w-x signifies that we're removing all of the permissions from from the primary groups and from others in all of the files in that particular file or folder. That's what we're doing there. Built in for Mac users, it's going to be built on Linux essentially. It is designed as a true server. A computer running Mac OS X server can support up to several thousand users. They might deploy the operating system server in a company that creates publications, advertising materials. Even school laboratories may use a Mac OS X server. It does include Apache Web Server. Permissions are going to be similar for Unix and Linux since it is Linux based. It does support TCP/IP. So I do have the ability, even with SMTP, to set up or use mail transfer protocol. Server admin tool can be used to create and manage user accounts, manage the file and print sharing. It does establish SharePoints, which are shared resources on the server. We just call them SharePoints. And it will log events in a very crude fashion, such as log in, log out, opening, creating, deleting files and folders. And last but not least, in Mac OS X, we can monitor and create print queues. Unix and Linux enable resource sharing by setting it up through the NTFS file system. It enables the computer to mount a partition or another computer and then access the file systems on the mounted partition. To use the NTFS Red Hat Enterprise Linux, we do that through certain services, the port map service, the RPC mounted service, and the RPC NFSD service. All these services facilitate NFS in Red Hat. So each one of these is designed to provide some management facility for NFS. Security that controls which clients use NFS is handled through entries in two files, the host.allow file and the etc folder, or the host.deny file. Facilitate whether clients are allowed to use NFS or not use NFS. And of course, if I'm going to be using NFS in combination with Windows drives, then I need to install a utility called Samba that will allow me to use server message block protocols very similar to what Windows uses in order to facilitate that. If I want to use Samba, then I can use it to connect another computer that is a sharing or that's going to be sharing a disk or a folder. I have to mount it. In order to do that, I go to the Go menu, select Connect to Server, and enter the address or server through the Browse button to find it. And that will allow me to, through Samba, connect a Mac OS to a Windows shared folder. Sharing disks, as far as security considerations go, anytime we share data, there is a certain level of risk associated with it. It is possible for non-authorized users to access files or use a printer or something like that. So all operating systems today now have security measures put in place. They allow us to limit authorization to resources. They allow us through security privileges to limit the users only to specific capabilities on a box, or to whether or not we want them to have the ability to change files, not change it, things of that nature. And of course, operating systems today allow access to shared resource printers, but we can do that through specific groups of people, same way that we can give them access to file resources through permissions. So we can set up on a print server the ability to manage print jobs, to just define what they can do specifically on the printer, cancel print jobs, and things like that. In Mac OS 10, turning on the file sharing through the System Preferences tool is what you need to do in order to allow sharing. Some of those resources that you can configure for sharing include the ability to share folders with other Mac OS 10 computers through the file sharing utility. We could also do web sharing through the web using the web sharing utility, and remote log-ons are going to allow another computer to remotely log into the system, which is very similar to remote desktop for Windows systems. Remote Apple events will allow other Mac OS 10 computers to send events to the computer, and of course turning on printer sharing is going to allow us to access the printer. Speaking of printer sharing in Windows systems, we can set a printer up, and once we do, we can configure that printer through the Print Sharing Properties tab. Different Windows versions have different steps in order to do that, but when you configure sharing, you're going to make sure that you're going to configure the shared permissions for that shared printer. There are different types of permissions that are available for printers. The print permission, just as you would expect, allows us to send print jobs and print your own stuff. Managing documents will allow you to manage the print jobs and sent by any other user. Manage printers will allow us to access and share and change share permissions, basically control the permissions properties in the permissions properties field. And then last but not least, we do have the ability to tailor permissions using the special permissions, which will allow whether special permissions are configured and whether they're going to be allowed or denied for users. Unix and Linux printing is going to be essentially the process of logging into the Unix and Linux server and printing to one of the printers there. Generally speaking, if you're using the Berkeley software distribution spooling system, there are three components for printing: the LPR print program, the LPD daemon, and which is kind of the equivalent of a spooler, and then the file etc. print cap to specify the printer properties. In Red Hat Enterprise, Linux, or even Fedora, since they're all based on the same thing, we're going to use the Genome Print Manager tool. It's a little simpler through the GUI interface than doing it through the command line. In Mac OS 10, there are two ways to set up printer sharing. The first method, of course, is to go into the system preferences from the dock, clicking Go, clicking on the applications, and double-clicking the system preferences, choosing sharing, check the box for printer sharing, and then closing the window. The second method involves opening the system preferences by the dock, clicking Go, clicking on the applications in the system preferences, double clicking on printer and fax, and then checking the box to share the printers with other computers. So let's summarize. Resource sharing is why networks exist today. They allow us to share the resources. In order to share the resources, we do have some things we have to do, our responsibilities as network admins. We use Active Directory in most organizations as a means of controlling and sharing resources. However, Linux and Mac both do provide for sharing of resources as well. Whenever network resources such as folder and printers are shared, it's going to be important to secure those resources. We can do that through a variety of ways. We've discussed some of those ways today. Certainly that is not an exhaustive list of ways that we can do that. When you configure the Windows resources, the process is going to involve generally creating security groups. That makes it easier to manage those resources. We want to have policies in place for all the user accounts that are going to dictate things like password policies, Kerberos policies, lockout policies. We're going to then set permissions to those user security groups onto the resources themselves, and we're going to configure those resources for sharing. Unix and Linux systems are going to use groups and users accounts and permissions very similarly to the way Windows does, though they're not as generally as tailored as NTFS permissions are. Mac OS 10 Server is a server version of Mac OS 10. It does have more extensive access to resources. The client operating systems such as Windows, Unix, Linux, and Mac OS 10 do come with utilities to allow for sharing resources and offering resources to share. All the operating systems are going to offer the ability to share printers, and network operating systems are going to continue to offer more and more and more ways to share, particularly securely share resources. Email, e-commerce, video conferencing, multimedia, these are all things nowadays that we can share through the operating system. Sharing is a fundamental aspect associated with why we use computers. It is something that, as network administrators, occupies a predominant and inordinate amount of our time, and so it becomes very important that we understand the ins and outs of sharing for the particular operating systems that we're using. Alright, so next time we talk, we'll be looking at more, our next lesson will deal with virtual machines and networking in general, and I look forward to seeing you then. Have a great one.